approaches are available to people regardless of how they choose to deploy. They might choose to keep all this stuff very private and specific to them, and they're just techniques, they're just tools.
There have been a number of people that are proposing architectures to where these are architecturally connected more at the core. And the general field for this is called cognitive AI, because that kind of mimics the way we believe anyway, that human behavior and the way our brain and reasoning work, that we have some things in our mind that is kind of real-time learning. And we have other things that are more long-term nuanced. And then it appears that our brain doesn't just have like one model, it's got many different types of models, but these are two. And so going back to kind of looking at cognitive AI, maybe there's a kind of combined hybrid architecture that doesn't just kind of band-aid these together, but architecturally they're actually joined. One area is called neurosymbolic computing. That's a subset of cognitive AI. And it does take the pattern matching of LLMs and architecturally combines them with the reason and real-time learning of knowledge graphs. A couple different approaches to this if you want the nerdy of it. One is called compression and vectorization. That takes those knowledge structures out of the knowledge graph and it puts it into a vector format such that it can be consumed by neural networks. There's the opposite too, which is pattern extraction, where we take a look at the neural networks and try to find out certain patterns that are in the neural network and extract that into symbolic logic that we can put into the knowledge graph. Well, you can imagine an architecture that uses both of these techniques to where each one is kind of updating each other in real time. So anyway, your word for the day, neurosymbolic computing, that appears to be the way things are going.
So wait, I want to go back to the swirly hand motion that you just employed, because that was the first time I've ever seen you do that. And I don't know how to feel about it, Mark. What was going on there?
That was the psychedelic test part of the show. But it's interesting that you talked about the first time. We are starting to see kind of this multi-model architecture start to emerge. I don't know, but I would imagine there may in the future be a third, fourth, or fifth type of model that is going to architecturally be brought into this. Again, we don't fully understand how the human brain works. We got bits and pieces kind of figured out. The same thing's true with artificial intelligence. We've got a couple models that show merit in different particular types of areas, but there are other forms of artificial intelligence besides LLMs and knowledge graphs. There are things like genetic algorithms. There are bubble knowledge and bubble intelligence. So there's a bunch of different wacky things that are out there that may prove to be very adept at certain pockets of problems and challenges, and that they may be folded into this. Little plug here, the November issue of IEEE Computer Society. There is an article in there where me and a colleague do kind of expand on an architecture that puts this together. So there is some literature out there on it. Again, we're at that literature phase. There's probably somewhere a lab with bubbling test tubes that have someone that is actually putting some of these together. But today, for the most part, it's two models working and exchanging information. But we're going to see the swirl, I think, coming up here.